So yeah, so question number 1 and question number 2 is done. Let's go to question number 3, and I'm going to ask students to answer. Others can write the answers in the chat box. Okay, so first answer will be given by Adrian. Which change of state takes place during evaporation? Which change of state takes place during evaporation? Yes, Adrian.
Liquid to gas.
Yes, very good. Liquid to gas. So it's B. Absolutely correct. Okay, next question, Advita. In which process do particles move closer but remain in motion? In which process do particles move closer but still they remain in
A, condensation.
A, condensation? Yes, that's absolutely correct. Now, what is condensation? Condensation is gas to liquid. Okay, condensation is gas to liquid. So definitely from gas to liquid, the particles come close. But we also know the property of liquid, that liquid are always in motion. So that's the answer for condensation. That's absolutely correct. Okay, next, Alishba, fifth one. Read the question properly and then answer. Others can write the answers in the chat box. The change that occur when a substance changes state, which are shown below. So it is solid to liquid W, liquid to gas X, reversible is Y and Z. Which process W, X, Y or Z is occurring in the following 4 situations? So the best way to do this question is butter melts on a warm day. So Alishba, butter melts on a warm day will be which of the 4 letters?
Miss W, solid to
It
liquid.
will be W because it is melting, right? Solid to liquid. We know that butter melts in when it's a warm day. So W. So in one, okay, in one, can I say W should be the letter? So can I say C and D cannot be the answer? Answer has to be from A or B.
Yeah.
Yes. Water condenses on a cold surface.
So Y.
Gas to liquid, that's correct. Which option there is in the second column, there is Y?
Miss B.
Yes. So we don't have to look for the third and fourth option. So in MCQ, when you have such a big question, okay, in MCQ, when you have such a big question, the note point, the tip is don't read the whole like the whole question. Don't spend time in solving all the questions. You have to be smart enough as where to look into the options, select that option, because every time you will get 2 options as a completely ruled out option. Means out of 4 options, 2 options will be such which will be completely ruled out, and you have to choose out of 2 options. So you have to be smart enough. Okay. Okay, next one, Aman, sixth one. The diagram shows a sugar lump in a cup of tea. Which 2 process must happen to spread the sugar evenly in the tea? Yes, Aman, you are adding sugar to tea.
Yes, miss. Miss, I think the first process will be dissolving and then the second process will be diffusion.
Very good. That's absolutely correct, Aman. It will be, so remember, if you are adding something to a liquid, since the liquid has little bit spaces in between, the solid will start first dissolving, because when you're adding sugar or maybe let's say salt to a water, so it will first start dissolving. It will start breaking into its smaller molecules, and then it will start diffusing, and that's how it spreads throughout the liquid. Okay, so sixth one is dissolving and diffusion. Okay, good. Next, Amishi. A sugar cube is dropped into a hot cup of tea. the tea is not stirred. Which statement explains why the tea becomes sweet?
Is it C, the sugar cube dissolves and its molecules diffuse?
Yes, that's absolutely correct. The sugar cube dissolves and its molecules diffuse. Very good. Yes. Okay, next question, Arpita. Okay, a crystal of potassium manganate 7 was added to each of the beaker. So potassium manganate 7 is the purple crystal shown in the diagram. One beaker contained hot water and another beaker is containing cold water. In both beakers, the purple color of potassium manganate 7 spreads out. Which results in explanation are correct? So first tell me, where will be the diffusion faster? Hot water or cold water?
The diffusion will be faster in the hot water because particles move faster at a higher temperature.
That's absolutely correct. So answer is C. So once again over here we have to, what we have to do, we have to eliminate the options. So we have studied that the color or whatever the diffusion takes place, it takes place faster in hot condition. So we know, okay, we know that in cold water, it will not take place. It has to be in hot water, okay? And it moves faster at higher temperature. So when temperature increases, it moves faster. Anybody is joining with iPhone? Is somebody joining with iPhone? Okay. Okay, next one, Nafisa. Which statement is an example of diffusion?
The smell of a cooking spreads through the house. D.
Yes, that's correct. So diffusion, the smell of cooking spreads through a house. That's absolutely correct. So ninth one, correct. Next, Nesdin. A few drops of perfume were spilled on the floor. A few minutes later, the perfume could be smelled a few meters away. Which two processes had taken place?
Evaporation and diffusion.
Evaporation and diffusion. Yes, that's absolutely correct. First, it will evaporate because perfume is in liquid state. It will evaporate and then it will diffuse. It will spread throughout the whole room. Good. Next one, Salma. The diagram shows the result of dropping a purple crystal into water. Which process takes place in this experiment?
A, chemical reaction, diffusion and dissolving.
Okay, so now let us check. So we know that diffusion and dissolving is definitely going to be there, correct? So answer has to be either A and D. Now over here, remember potassium permanganate, it's a crystal. When it is dissolving and diffusion which is taking place, okay, for potassium crystal to just spread and convert its color, I mean to dissolve in water and to diffuse and the color of the water becomes purple, chemical reaction does not take place. There is no chemical reaction. Remember this, it's only dissolving. So answer will be D. It's not A. Okay, everybody? Okay, and the next one, Samuel, two gas jars, each contain a different gas. The gas are connected and covered slips are removed. The diagram shows what happens to the particles of gas. What process has occurred?
Diffusion.
Yes, very good. It's diffusion. Intermixing of particles from a region of high concentration to low concentration is diffusion. Okay, going back to Adrian. A liquid is heated until it boils. Which result shows that the liquid in the test tube is pure water?
The thermometer reads 100.
Yes, that's absolutely correct. The thermometer reads 100 degrees Celsius. So remember, we had studied that when do we say that the liquid is pure or a substance is pure? Because they will have a specific boiling point and melting point. Okay, they will have specific boiling point and melting point. Okay, 14th one, Advita. An attempt was made to compress a gas and a solid using the apparatus shown. Which substance would be compressed and what is the reason for this?
It's B because gas molecules are farther apart, so it's easier to compress it.
That's absolutely correct. Very good. So it's gas because the gas molecules are very far apart and they can compress very, 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 very easily. Okay, next, 15th one. 15th one, Alishba. A gas jar of bromine vapor and a gas jar of air are set up in a diagram 1. The glass slide is removed. Diagram 2 shows the appearance of the gas jar after 1 hour. Which statement explains why the bromine and air mix together?
Miss B, molecules in bromine and air move randomly.
Yes. So over here, it's not about any density, but yes, it's about bromine and air, which is moving in random motion. So that's why they will mix together. So that's diffusion. That's absolutely correct. Okay, next, Aman. The diagram shows a cup of tea. Which row describes the water particles in the air above the cup compared with water particles in the cup?
Miss, 1 minute. Miss B, moving faster and they are not closer together.
B. So close together is a crossover here.
Yes, Miss.
Okay, so over
Because it's a
here,
gas, right?
yes. So which row describes? So let us understand this. Aman, your answer is correct, but let us discuss this. Which row describes the water particles in the air above the cup? So can I say air above the cup is vapor, which means it will move
Yes, ma'am.
faster? Yes, so that's correct. So answer has to be from A and B. Compared with water particles in the cup. Now, water particles in the cup will be what? I mean,
Liquid.
they will be close together. So water particles on the top in the vapor, they will be far apart. They will not be close together. So close together will have a cross. So answer is B. Absolutely
Yeah,
correct.
that's correct.
Yeah. Okay. Next is Amishi. What are the process W, X, Y, and Z in the following diagram? Solid to liquid will be?
Wait, miss, I don't understand the question. So basically from A, B, C, D, we have to decide which one is the process of solid to
So yeah,
liquid.
so W, you have to check the column. So over here, W is solid to liquid. Okay.
Melting?
So melting. So W has to be melting. It cannot be condensation. So can I say A and B cannot be my answer? It has to be from C and D.
Yes.
Okay. What is liquid to gas?
Liquid to gas, boiling.
Boiling. So X has to be boiling. Which option has X as boiling?
A and C.
Okay, A and C. But we know that we cannot, means A is not our option. So what will be my option? What will be
C.
my answer? C. Okay, then why we know liquid to solid is freezing and gas to liquid is condensation. So C is my answer. Amishi, now are you understanding?
Yeah, now I understand.
Okay. Okay, next, Arpita. particles moving very slowly from an area of high concentration to an area of low concentration. Which process is being described above?
A substance diffusing through a liquid.
Very good. Because over here they are talking about particles are moving very slowly. See, area of high concentration to an area of low concentration is diffusion. We know that. It's diffusion. But when we talk about particles are moving slowly, so they are in motion, but they are not moving as fast as it is diffusing in the gas. So they are moving very, very slowly. So it's going to be in liquid. So yes, very good, Arpit. Okay, next, Nafisa. Which diagram shows the process of diffusion?
C.
Yes, it is C, where the intermixing of particles takes place. That's correct. Nesden, 20th. In which substance are the particles close together and slowly moving past each other?
Water, miss.
Yes, that's correct. Because particles are close together and slowly moving means it has to be liquid. So air is gas, ice is solid, steam is gas, and water is liquid. Okay, 21. Salma. The diagram shows the arrangement of particles in 3 different physical states of substance X. Which statement about the physical state of substance X is correct? Read all the statement and tell me whether the statement is correct or not. Particles in state 1 vibrate about fixed position. Okay, tell me what is state 1, Salma, first.
Liquid.
Okay, liquid. State 2
Gas.
and state 3 will be solid, right?
Solid. Yes.
So particles in state 1 means particles in liquid vibrate about mean position. Is this statement correct or incorrect?
It's incorrect.
So this statement is incorrect because, okay, what will be the correct statement? Salma, wait, you don't answer. Anybody?
Okay.
Yes, Arpita.
That solid state 3 vibrate in fixed position.
Yeah, so this has to be state 3. Okay. Now, Salma, tell me, state 1 changes to state 2 by diffusion. Liquid to gas, is it by diffusion?
No.
So it will be by what? State 1 to state 2 will be by which process?
From liquid to gas, it would be boiling.
Yes, very good. Liquid to gas, it has to be boiling. So even this statement is incorrect. State 2 changes directly to state 3 by condensation. State 2, which is gas, to state 3, which is solid. Gas to solid, is it by condensation?
No.
So then it is by what?
Deposition.
Yes, very good. So this is by deposition. So even this is incorrect. The substance in stage 3 has a fixed volume. Is this statement correct?
Yes, solid has
Yes.
fixed volume.
Yes, so answer is D. Okay. Samuel, in which change do the particles move? Okay, this is a repeat question. It's same as 1. So Samuel, 23rd one. Aqueous lead nitrate and aqueous potassium iodide are added to a dish containing water. A yellow precipitate is formed after a few minutes. Which process occurs between the precipitate forms?
Is it a diffusion?
Yes, that's absolutely correct. And the last question, I want everybody to write the answer in the chat box. Everybody to write the answer in the chat box. The diagram shows how the molecules in the exhaust gas diffuse in the air. Okay, the molecules in the exhaust gas and molecules in the air. Now they are diffusing, they are intermixing. How they will diffuse? Which statement describe what happens to these molecules next? The molecules fall to the ground because they are heavier than air molecules. We'll just read all the options first. The molecules go back together as they cool. The molecules spread further into the air and the molecules stay where they are. Okay, now let's say if there is a car which is going and there is like, let's say too much traffic which is there and the cars are releasing exhaust. So does that exhaust, like will the smoke or something will fall down to the ground or they will spread apart? Aman?
Yes, miss.
They will fall to the ground or they will spread apart. What will happen? Because at the end it's air, it's in the air. So what happens to the air?
Miss, I chose fall to the ground mainly because I think they're heavier than the actual air particles because it's smoke. So I don't think necessarily that they'll fall to the ground, but maybe they'll go to a low point.
Yeah, that is true. But you know what happens over here? Your thought process is correct, Aman, over here. But over here, the question says that when they are intermixing in the air, now see, air is a bigger volume. Okay, air is a bigger volume. Now the particles which will be there of the exhaust will also contain some gas particles and also some, pollutants, small pollutants. Okay. Now if air is a bigger molecule, so that pollutant will be carried away along with the air. It will spread apart. Okay.
Oh, okay.
It will not settle down. Because at the end air is a bigger molecule. It is air which is taking away those molecules with it. Okay.
Yes, miss.
So those who have written answer A, are you understanding why the answer is not A? Because I have got two answers, A and C. So there were few students who wrote answer A, there were few students who wrote answer C. So those who have written answer A, any doubts? So answer is C over here. Okay.
Okay.
Yes, so this completes our MCQ question, and now let's move on to the structured question. So in structured question, let us do from this question. Okay. Okay. Question number 6. The diagram shows, so this is about the heating cooling curve, which we had discussed in our on Sunday in our last lecture. The diagram shows a heating curve of a sample of compound X. Okay. Is X a solid, a liquid, or a gas at room temperature 20 degrees Celsius? Yes, what do you think will be a compound X at 20 degrees Celsius? And why students have switched on their cameras, you have to turn on your cameras. Sorry, students have switched off. So please turn on your cameras. Yes, Arpita.
Can I say the
Yes,
answer?
yes, and yes, Arpita.
I
Yes.
think compound X is a liquid at room temperature 20 degrees because it shows at 15 degrees it's like between the solid and liquid stage.
Yes, miss, I would agree.
Yes, that's absolutely correct. But what we had studied that this plateau, the stationary phase, has to be melting point and boiling point, which means that's the phase where they exist in both the states. So this 15 degrees Celsius is its melting point. And BC is the region where the solid is still converting into liquid. It has not completely converted into liquid. It is still a process. It's an ongoing process. And this is boiling point, where liquid is getting converted to gas and it's still an ongoing process. So when they're talking about is X a solid, liquid or gas at 20 degrees Celsius. Now 15 is over here, 80 is over here. So they are talking about at 20 degree. So 20 degree means it has to be in this area, in this region, which means it has already converted into liquid. And now in that region, the CD region, it is going to be completely liquid. So over here, it's going to be liquid state. Next, write an equation for the equilibrium which exists in the region BC. Now BC is melting. So which two physical states will be present, Nafisa? Which two physical state will be present? If it is melting, which two physical state? Aman, you can write your answer in the chat box. Others can write the answers in the chat box.
Solid and liquid?
Yes, solid and liquid. So when they are talking about equilibrium, now over here, very important, it's a 2-mark question. So they will not give you 2 marks for writing solid and liquid. So the equilibrium will be, the answer will be X, because they're talking about compound X in solid state, reversible arrow, X liquid. The reversible arrow has 1 mark. Remember that the reversible arrow has 1 mark. It's a 2-mark question. So you have to write what is important. X solid, arrow X liquid. Okay. Next, Samuel is going to answer this. Name the change of state which occurs in region DE. Name the change of state which occurs in the region DE. Yes, Samuel.
Miss, the answer is gas.
They are talking about change of state.
Liquid to gas.
Name the change of state which occurs. Yeah, okay, you can write gas. That's correct. Or to be precise, it's actually evaporation or boiling. So change the state, or you can also write liquid to gas. Only gas not accepted, because name the change of state which occurs in region DE. The whole thing they are talking about. So it is liquid to gas. Okay. Next, explain how the curve shows that a pure sample of compound X was used. How do we say that the compound is pure? Explain how the curve shows that a pure sample of compound X was used. Again, it's a 2-mark question. Okay, so 2-mark questions. So over here, we need to write 2 points. So we will write that in region BC. What happens in region BC? The solid melts and there is a fixed melting point. So in region BC, solid melts. This part holds 1 mark. And there is a fixed melting point. This part holds 1 mark. And that is how you get 2 marks. Another answer which you can also write, or in region DE, liquid boils and there is a fixed boiling point. Okay.
I have a question.
Yes.
How would the graph look like if the substance was impure?
If the substance is impure, so a note point, substance is impure. If the substance is impure, the boiling point will increase. There will be an increase in boiling point, and the melting point will decrease. So
How
if
would
there
it
is,
look like visual? Like how?
sorry,
would the
how?
graph- How would the graph look like visual?
Now the graph will be, now see, DE is my boiling point, na? This is my boiling point, correct? So this will go above. That region will be on the top. And the BC region is my melting point. So this will be over here. Means it will start melting before 15 only. So the melting point curve would be below and the boiling point curve would be above. Okay, so that is what you have to remember. Substance is impure, the boiling point will increase and the melting point will decrease. Okay, so this don't worry about how you will write these answers and all. The worksheet I will be sharing with you with the answers written on it, so you can revise that worksheet. So don't worry. So let us do one more question, same type of question. So it will be more clear to you guys. Okay, let's do question number 3. Compound X is a colorless liquid at room temperature. A sample of pure X was slowly heated from -5 degrees Celsius, which is below its melting point, to 90 degrees Celsius, which is above its boiling point. Its temperature is measured every minute and the results are represented on the graph. Complete the equation for the equilibrium region in the BC. Now BC, see there will be always two stationary phase, means two lines. One line will be melting point and one line will be boiling point. That is what it will be there for every cooling heating curve. So BC region is melting point. So tell me what will be the state? X solid, what will be on the right hand side? What will be there on the right hand side?
X liquid.
Yes, it will be X liquid. So over here, your job has been done easy because already the equilibrium, that is the reversible sign, is already given. Next, what is significance of temperature T degrees Celsius? What is that which tells me from the graph? T degrees Celsius. What info is given? TE, can I say TE is exactly at that stationary phase? So what is that T degrees Celsius tells me?
It's the melting point.
Yes, it's the melting point. Everybody is understanding or no? If you are not understanding, please ask me. Everybody is getting Arpita, Salma, Nesdin, Alishba, Aman, Samuel.
Yes, miss.
Okay. Okay, let's talk next. What is the physical state of compound X in region EF? I want everybody to write the answer. Write the answer for this. What is the physical state of compound X in region EF? Yes, very good. Yes. The state. Look, read the question. Physical state. Physical statement, it will be either solid, either liquid, or either gas. One, two, three. 4, 5, 6, 7. More 3 students to give me the answer. Guys, quickly, come on, it's a one-word answer. What is the physical state? Yes, Aman, that's correct. So over here, we need to write only that word. Samuel, you are left with answer yet. I have not received your answer. Samuel. I think okay. So yes, EF, since DE is its boiling point, so boiling point means EF will completely be gas. Okay, now this question, which this last one we had discussed just now, what would be the difference in the region BC if an impure sample of X had been used? Yes, Salma.
The boiling point will increase and the melting point will decrease.
So over here, BC is which region?
It is a melting point.
So what answer you will write?
The melting point will decrease.
So can I say the region BC will be below its melting point? The line will be
Yes.
lower. That's absolutely
Yes.
good. Arpita, good. So just now we studied that for an impure substance, the melting point will be lowered. So what would be the difference? So if I plot a graph, same graph, but if the substance is impure, I will see that my BC region will be below its melting point. So we can say that the line BC will be lower. Line BC will be lower. So yes, this is one kind of a question which can be definitely asked in your chapter, which is your states of matter. Yes, Nafisa.
Miss, can you share your screen again? My screen has gone black.
Sorry, can I?
Can you share your screen again? My screen has gone black.
Yeah. 1 second. Yes, now?
Now it's fine.
Okay. Okay, let's do another question. Okay, let's do this question. Question number 2. Question number 2 says, concentrated ammonia solution gives off ammonia gas. Concentrated HCl gives off hydrogen chloride gas. Ammonia, which is NH3, and HCl, which is HCl, are both colorless gas. Ammonia reacts with hydrogen chloride to make a white solid ammonium chloride. This we had discussed when we were doing our chapter. So the questions are based on this. So let's say after 10 minutes, a white solid forms in the tube where the gases meet. Write the chemical equation for the reaction of ammonia with hydrogen chloride. So over here it will be NH3 plus HCl gives ammonium chloride is NH4Cl.
Yes.
Those who don't know the valency, it's okay. We are going to learn about the valency, so don't worry about that. So the chemical equation will be NH3 plus HCl gives NH4Cl. Okay. Name the process by which ammonia and hydrogen chloride gases move in the tube. What is that process?
Diffusion.
Yes, the process is diffusion because both are gases. So yes, it's diffusion. Next one. Next question. Next question says, at which point A, B, C, or D does the white solid forms, and explain why the white solid forms at that point. This is HCl, this is NH3.
Miss A.
Yes, we had studied this, that NH3 is lighter molecule.
Therefore, the
It's
molecules
lighter.
travel
Yeah, because
faster.
MR is 17 for this. And this is a heavier gas. Because
Yes, so the
the
molecules
AR,
travel
yeah,
faster.
the MR will be 36.5. So as the HCl is a heavy molecule, as it will pass slowly, it will diffuse slowly till the time NH3 will quickly come and it will be the point near to the heavy particles. Okay, it will be point near to heavy particle. So it will be point A. The reason explanation is the ammonia particles are lighter. Ammonia particles are lighter and can diffuse faster than HCl. Okay.
Yes.
Okay. Next, let's do this question. The experiment was repeated at high temperature. Okay. Predict how the results of the experiment would be different. Explain your answer. Now it's a 3-mark question. So we know one thing. What happens at high temperature?
Miss, molecules move faster and gas will diffuse faster because they're
Okay,
moving
one
faster.
second. Arpita, no, we are not supposed to remember the molecular mass because atomic mass will be given to you in periodic table. So from periodic table, we can calculate molecular mass.
So like during a test, would we like be given the periodic
Yes,
table?
periodic table will be given to you. You are allowed to use even calculators. So when we will be doing I think maybe some chapter where we calculate molecular mass, so calculators will be required. So you are allowed to use calculator, and for each paper they will be giving you periodic table, which will be at the end of the paper. So you don't have to worry about it. Okay. Okay. Yeah. So what happens at high temperature? The diffusion will be faster or slower?
Faster, Miss, because the molecules are moving faster at higher temperature.
Yes. So that is our one mark. Yes, Arpita. What else we can add?
According to the kinetic theory, when the higher the temperature, the particles have more energy,
Correct.
which will make diffusion faster, but like it will also increase the rate of collision.
Correct. So now over here, yes, very good. So over here, since it's a 3-mark question and they are asking the answer with respect to the solid formation of ammonium chloride. So one statement is correct that yes, the particles will diffuse faster. Second statement, why the particles will diffuse faster? The reason because molecules will gain lot of energy. Yes, but the third statement will be the solid which is formed, that is the ammonium chloride. Tell me, will it be formed in much less time, or it will take more time as compared to the original experiment?
Less time.
Less time, correct? Because if the diffusion is faster, if everything is happening at a faster rate, the solid formed will be much faster. So that's how the 3 points we are going to write. So the experiment was repeated at high temperature, and the question they are asking, predict how the results of the experiment would be different. So number one, the result of the experiment would be different is that the solid, white solid NH4Cl will form faster. Okay, will form faster because as temperature increases, particles gain more energy and rate of diffusion will be faster. 3 marks we have to write properly 3 points. So this 3 points will give you 1 mark. Particles gain more energy and diffusion will be faster. So these are the 3 points which will give you 3 marks, because when you write structured paper, if it's for 2 marks or 3 marks, they don't expect you to write stories. It's not required. But you should mention what is needed, and that is how you will get your marks accordingly. Okay. So this was the question about one of the question. Let's do one last question for today. Okay. So this is for bonding. So it's from bonding. So that's a different chapter. Next one, compare the movement and arrangement of molecules in solid nitrogen to those in nitrogen gas. So now they are talking about compare the movement and arrangement. Okay, they are talking about movement and arrangement. So what will be the answer? In solid nitrogen, okay, in solid nitrogen, what will be the pattern, the movement? In solid nitrogen, can I say there is a regular arrangement of particles?
Yes, yes.
There is a regular arrangement of particles. Then we can also write that particles are closely packed and they vibrate about mean position. This is about solid. What about gas nitrogen? So basically they have given nitrogen, but actually they are asking us solid between solid and gas. So how the particles in gas, how they are moving? Can I say they are moving randomly? The gas particles are moving randomly. Moving randomly and are far apart from each other. Far apart from each other. Okay, next. A sealed container contains nitrogen gas. The pressure of the gas is due to the molecules of the gas hitting the wall. So the pressure is because of the heating the walls. Yes, Arpita, that's absolutely correct. Use the kinetic theory to explain why the pressure inside the container increases when the temperature increases. So always you have to use the same notations. If the temperature increases, the particles gain more energy, there will be more kinetic energy and the collision will be more. This 3, you can say important lines, the mantra of this chapter, that is, whenever the pressure will be more, the particles gain energy, the kinetic energy will be more, and the rate of collision will be more, or the rate of diffusion will be more. Okay, so the pressure inside increases when the temperature increases. So what happens? The particles gain more energy. Kinetic energy increases. Kinetic energy of particles increases. And since over here they are talking about hitting the wall of the container, so the particles will collide more frequently. Okay, and let's do the last 2 parts. Okay, now this is the apparatus. Okay, this is the apparatus. Can be used to measure the rate of diffusion. This is the gas syringe. Okay, there is a constant pressure applied. There is a metal foil so that the gas escapes through small hole in the foil. Okay, now over here the temperature is 30 degrees Celsius. This is 30 degrees Celsius, and over here it is 38 degrees Celsius. Explain why nitrogen gas diffuse faster than chlorine gas. From periodic table, atomic mass of nitrogen is 14 and chlorine is 35.5.
Because nitrogen is lighter than chlorine.
Yes, very good. Because when we talk about N2, now nitrogen is a diatomic gas. So molecular weight will be 2 into 14, which is 28. And for chlorine, it will be 2 into 35.5, which is 71. So explain why nitrogen gas diffuse faster than chlorine. So 2 marks. So we have to write that nitrogen has less molecular mass than chlorine. That is 1 mark. And nitrogen diffuse faster than chlorine. And the last question, explain why nitrogen gas diffuse faster at higher temperature. What happens to molecules at high temperature?
They gain more energy.
Yes, because it's a 1 mark question. So we need to write our answers in that way. Over here, we need not explain everything. So diffuse faster at high temperature reason because the particles, or we can say the nitrogen gas particles, N2 gas particles gain more energy. So if they gain more energy, definitely the rate of diffusion will be faster. So these are few questions which can be asked, like similar type of questions which can be asked from the chapter particulate nature of matter. So this the thing which we have discussed over here, I will be sending it to you guys, okay? And also the recording might take 1 day because it takes time for rendering. So it takes 1 day. So I will be giving you maybe by the day end or tomorrow morning. But the worksheet, I will be sending it in some time quickly so that you can revise. And next class, we will be doing another chapter because this chapter we have completed the concept as well as we have learned how to solve the question. Some questions are still remaining, which I would like you guys to do it on your own. And the answer of that, I will share it in 1 or 2 days. Okay. So the homework question, I will mark the question as homework, which is related to the topic. Okay. Because in this worksheet, there are certain questions which are not related to this topic. So don't panic about that. Okay. So I will mark the questions as a homework question. Try to do this as her homework, and the answers of it, I will be sharing it in a day or 2. And if you have any doubts, you can definitely ask me in the next lecture, or you have my WhatsApp number, so you can ask me over there as well. Okay, guys, so we will be meeting on Sunday, okay, with another chapter. So till then, thank you so much. Bye-bye. Have a nice day and have a nice week. Take care. See you on Sunday.
Bye.
Bye.
Bye, miss.
Bye,
Thank you,
miss.
miss.
Bye. Welcome. Bye-bye.
Bye.